what we have here is a one gang switch. So I'm going to open a one gang switch so that we see the connection. Now, remember, we have no neutral in a switch connection. Neutral has nothing to do with the switch connection. Don't mind this black cable you are seeing here. It's just a traveling neutral going to a separate place, but following this route. But it has nothing to do with our switch connection. So let's pay attention to understand what is happening here. If you look here, we have common. This place is written common. And if you look here, you're going to see L1, L2. So if it's a two-gang switch, you're going to see common here. Then you have LO1, LO2, you have LO11, LO just like that. But this is just a one-gang switch, all right? What I mean by gang is just this stuff here, all right? So let's understand what is happening here, okay? So we have one wire common. This common wire is a live cable. It's a live cable coming directly from the distribution board. Okay, from the distribution board, it gets to a switch, and the terminal it lands in the switch is the common terminal. Okay, then this other terminal LO1 is coming from this red color wire is coming from the live terminal of our lamp holder. So I have a lamp holder here. This LO1 comes to one terminal of the lamp holder here, all right, while the neutral here is coming directly from the distribution board, from the neutral link, all right, but the wire from here will come to this LO1, all right. Then whenever we switch on, current will flow. Is coming from the distribution board. From here, it will have a contact to this place, and then it will enter one terminal here. And remember, neutral has already been supplied, so the bulb will turn on. So that is why when you switch on, it will go on. When you switch off, you are only interrupting the live cable from the distribution board. It will switch to the red contact of the lamp holder. Then the neutral is already supplied, so the lights will turn on. Just like as I explained earlier, a switch can supply another switch. You may not always need to run from the DB to every switch. A switch can pick the hotline from another switch, and this is what's happened here. All right, so this is the hotline to this switch, and if we check this hotline, there is a joining here. Okay, so this joining this one went to supply this fan regulator from this common wire carrying the current from the distribution board. It has supplied to this switch. Then from here, other switches picked. All right, so the first place that picked from here is this fan regulator. Then if you observe, another one went across. Look at this cable here. Look at this cable. It went to the other side of this wall. I'm going to show us. On the other side of this wall is another one gang switch. Okay, so it's picked from this same common coming from the distribution board. So instead of going to the distribution board and picking live cable to supply here, we now picked it from here. Okay, so if that very circuit breaker is having an issue, this light, and every other light that is being controlled by this switch will not turn on. And remember, the neutral is supplied directly from the distribution board, and the neutral from the lamp holder can still be looped to another lamp holder. All right, so this is how it works. So this is a one gang switch. So if it's a two gang switch, we are going to see common two places. All right, so okay, let me open a two gang switch and show us so that we can understand this better. All right, so right here is a two gang switch. So what I mean by gang are these switch points. We have a two gang switch. Now this is inside a two gang switch. Just like as I told us, neutral has nothing to do with a switch. Okay, so let's see the common and live just as we saw in a one gang switch. Okay, so if we look here, we are going to see common. So this is the common, and just like we've known earlier, common is the point of, where we get the energy, the energized cable. That is where it comes. Then we have the LO point. So for this first gang, we have the LO1 and LO2, and for the second gang, we have LO1 and LO2. Now let's see what happens. This is the common where we have the energized cable. So this very energized cable is coming from somewhere. This is a water heater switch, okay? So the ones from DB, live, the red one, and the neutral. Okay, so for a switch connection, we're only concerned with the live. So it picked live from this water heater. Okay, then the live entered into this first gang. So the live entered into this first gang. Then to supply this second gang, instead of going again from the distribution board, we looped to this point. Okay, so these ones, LO1, LO1, this is LO1 for one gang, this is LO1 for the second gang. All these LO1s are from different lamp holders. Okay, so this very gang is controlling this very light. This is from one lamp holder, and this one is controlling this lamp holder. So but their supply is from the same source. Okay, so if anything happens to the circuit breaker supplying this very water heater, the water heater will not be functioning, this light will not be functioning, and this light will not be functioning. Okay, so unless the fault is rectified or the circuit breaker is replaced, then the water heater will start working and all these lighting points will start working. So I just want us to understand the connection. This is the common. The common is picked from here. The live is picked from here. From the DB, it came here. From the distribution board, it came here. Then from here, this gang picked. Instead of going to the distribution board again, we now looped from here to supply this very gang. Okay, this is a lighting point and this is the lighting point. Don't mind the blacks. The blacks are just traveling. This black picked from here, from this water heater switch, to supply somewhere else, maybe a lamp holder or a fan. So this is just a way of explaining what two gang means. So if your light is not turning on, so if your light is not coming on and you've confirmed that the bulb is not burnt out and the lamp holder is okay, so this is the next place you're coming to check. A switch can be bad, so you simply replace it. So you cannot test voltage across this live terminal. So you can only test voltage between these terminals and any of the black, any nearby neutral. Okay, these black cables are the neutral. You can only test for voltage between these points and any of the black. So had it been you met a switch where you have no black cable traveling, what we do is you look for the nearby socket. You can pick the neutral and test if this cable coming from the distribution board is energized. So if it tests positive to voltage, then you are sure that the lines are in order. So what you need to do is to just simply replace your switch. So but if you test and you confirm that there is no light from this cable coming from the distribution board, then you go to your DB and check the particular circuit breaker affected. So that is just as simple as that. So with this, I believe we've understood the switch connection. So if your switch is bad now, you can always know how to replace them. So but one more thing, in most cases we like to mark something maybe with a sellotape. You denote the live cable. So when I do my own wiring, I just tape something on it so that any electrician or the homeowner, once you open the switch, you can identify which one is the live cable carrying current. So even though it's not taped, you can identify the live cable by the contacts, the terminal or its termination where it's being fitted. So once you see any cable at the common terminal, know that it is carrying current. It's the one carrying current from the supply. So this is the switch connection for conduit wiring. Over here is a special kind of switch known as water heater switch. So let's open it and see what is inside. Okay, so inside the water heater switch, the cables are so short I can't open it fully. Inside the water heater switch, we have the input and we have the output. So the input is just live and neutral, and the output is also live and neutral. Okay, so it's actually controlling both the neutral and the live. So from the DB, you pick live and neutral, all right, live and neutral, and then this is the load. Okay, you have the input from the DB, and then the load, live and neutral as well. So when you switch, is transferring both live and neutral to the load. So what just the second wire you are seeing here is a traveling cable. Okay, is a traveling wire, is supplying neutral to another point. Okay, so this is just the connection. This is just the connection of a water heater switch. So we use this for water heater, and then we use it for things like air condition that has, you know, higher power ratings. Okay, so the first terminal, live and neutral, is the input to the load, maybe your water heater or your air condition, while the other one down here is the supply, live and neutral. So supply, live and neutral comes to the one end, then the load contacts live and neutral to the other end. So once you switch on, your load turns on. So this is how such a switch is connected.